Hello students, now in class 12th today I will tell you the equilibrium of a charge placed between two charges Q1 and Q2. So our topic is equilibrium of charge Q. This is our topic. Suppose 2 point charges Q1 and Q2 be placed at points A and B at distance r apart. This means that you are given this charge Q1 at this point A, this is charge Q2 at this point B. Here we are given a charge Q. A charge Q is placed between Q1 and Q2. Now these two charges Q1 and Q2 are of the same size as same nature, that of the charge Q at the point O. Now the distance between them is R. So the force due to this charge Q1 on this charge Q, that will be in this direction. This is now Fa, and the force on this Q due to this Q2, this is now force like this. This is now your Fb. Both will repel to each other, repel to this charge Q. Force due to charge Q1 on the charge Q. This is equal to Fe. Now then, this Fe, suppose this we are given the distance x. This distance is suppose x. Then what we have? That this Fa equal to 1 upon 4 pi epsilon naught Q1 into Q upon x square. This is the remaining distance with r minus x, clearly. This is now r minus x, so much. So this is now towards B. Towards B. Now force due to charge Q2 on the charge Q equal to Fb. So this Fb is how much? Fb is 1 upon 4 pi epsilon naught into Q2 into Q upon r minus x whole square. This is now towards A. Now to find the equilibrium, what does it mean? If suppose charge Q is displaced slightly then after displacing to this one, the charge must come to its initial situation. Then this is said that the charge Q is at equilibrium position. If this does not come to the equilibrium position after displacing, it means that charge Q is not in equilibrium. So let us see what happens that when the axial displacement is given to it. So now two situations. There are two situations. What? Number one, let charge Q be displaced towards A. Towards A on this side. This means that this distance will decrease, x will decrease, and this distance will increase. So when this is charge Q is be displaced towards A, then FA greater than FB. FA greater than FB, and here we are looking that this FA and FB are in opposite direction to each other. This means the resultant force. Resultant force F equal to FA minus FB, because FA is more than FB, so clearly we have to take this FA minus FB. So when this FA minus FB and this F is greater than FB, then in that case the charge Q will not go back to the mean position. Hence the charge Q will not go back to its original position. It means that the charge Q will remain in the displaced position. It means the charge Q will remain in displaced position. So what is the conclusion? That if the charge Q is given the axial displacement, it will not remain in equilibrium. Conclusion: the charge Q for axial displacement the charge Q will be in unstable equilibrium. It means that the equilibrium cannot be here. And now case 2. Suppose this is the charge Q1, this is now charge Q2, and this is now point O where this charge Q is placed, and this is now distance between them. Suppose this charge is given the perpendicular displacement. Perpendicular displacement. Suppose this charge is now taken to be at this point. Then what will happen? Then this charge is taken at this point. This is now you are given the distance x. Then what will happen? That this charge will also repel to this one, and this q1 will also repel to this q. So this charge may come towards its mean position. Then you can see that if the forces are resolved in the components, then the resultant force will come out towards this mean position O. Let charge Q is given displacement in perpendicular direction. This is now new displacement in the perpendicular direction. Both the charges, Q1 and Q2 will repel to charge Q. So this charge Q may come towards the initial position. As a result, the charge Q will return to its original position. So what is there? The conclusion of this is for perpendicular displacement, the charge Q will be in stable equilibrium. So for perpendicular displacement, this will be in the stable equilibrium, but for axial displacement, this is no more in stable equilibrium. So this is what the equilibrium of the charge placed between the two charges Q1 and Q2. So for equilibrium only we have to find whether the charge will return to its initial position after some displacement or not. If it is coming back, then this is a stable equilibrium. If it is not coming back, then this is the unstable equilibrium. So this is what the discussion of the charge, the equilibrium of the charge Q placed between the charges Q1 and Q2. Sometimes the question is asked in the NEET exam also, that if a charge Q is placed between the two charges in Q1 and Q2, then its equilibrium will be first for axial displacement, for perpendicular displacement, for both axial and perpendicular displacement, and none of the axial displacement and the perpendicular displacement. Thank you very much.